navigation is like feedback from the ground. We're telling the satellite where to go, where it is, figuring out where it is, where it needs to move to. And so if you go to the next slide. So autonomous navigation is doing all the same stuff, but cutting the person out. So computer doing all of this analysis. And it's all being performed out there, obviously, because as you go out further and further in space, you're losing that ability to communicate with the satellites. So these are a couple of the missions. I'm not sure if you guys are given these PowerPoints to look over, or I'm not really sure of the background, but this is just an example of a few missions which use some of this. So if you want to go to the next slide. Go to the next slide real quick, see what he's talking. Okay, go back. So what he's just trying to say here is break it down into two different aspects. There's optical navigation, as far as we are in some far off distance, we want to go somewhere. I'm looking and I want to go to Pluto or something. So I'm looking at backgrounds, figuring out where I'm pointed, which direction I need to go. Now, if we actually wanted to land on Pluto, we're now close enough to look at images. Now we're doing actual landmark and tracking out stuff. So on the next slide, he kind of shows this. So what they use are the stars to locate where you are. So if I take images over here, okay, we know what these stars look like. And now I know approximately I need to rotate over here. Okay, I rotated too far. These stars, I know I need to rotate back. Okay, I'm coming. And then we're getting now closer to it, and we're just doing the landmarks. So later, there are two activities which we can use these helicopters to do each one of them. I'm gonna give you the option to kind of choose which one you may want to do later on. So we'll get there in a little bit though. And this is just an example of how a computerized arm using kind of this autonomous feature and optical navigation. It has optics in order with which it's seeing something. So it starts to move the robot arm, and then there's, the system is telling how much we moved, which direction it moved, and then next slide. And so we're just feeding that back into the computer. Okay, well, we need to move this far, and what are we trying to grab? So this can be seen a lot with some of the new surgery techniques that are happening. Doctors are using this, so kids nowadays might be good doctors, since that hand-eye coordination, playing with games. It's almost like a game now. I used to play with, what was that? That little surgery game, hit the little sides. Operation. Now they get to play with joysticks, so I went too far. So this is the driverless car. This is the Google car, basically. So we want to connect here to here. That's all we're trying to do. So if you go to the next slide. So they have a camera, LiDAR system, the thing that cops tag you with when they give you speed tickets, and all these speed cameras, same idea. So it's taking information of everything around it, and then it's going to here, processing the information, giving it gas, and then you get the motion. So next slide. So one of the missions that I work on at the University of Arizona is the OSIRIS-REx mission, and this mission is going to an asteroid and collecting space dirt. And it's unique in its mission, in which we've never been to this asteroid before, so we're going there. We have a clue what to expect, but it might be something we don't expect. So we're going to this asteroid, and we're using all of this autonomous navigation, optical navigation, everything I've talked about, in order to go to this asteroid. So we can go ahead and go to the next slide. Keep going. So one of the important things about this is, when we're in space, what's the coordinate system in space? Or how do I know where the origin is? How do I know if I'm looking up? How do I know if I'm looking down? We have to, you have the ability to establish whatever coordinate system you want. And so for all you math people, this is great. Actually get to relate it from, these X, Y coordinates that you teach in school to something that is real and what they can understand. So if we're looking down, we have global coordinate systems, obviously, that everybody agrees on. We have longitude, latitude. That's what we use for the mapping of the Earth. So if you go to the next slide. On here, it's hard to see. He chose an axis system. Oh, no, go back. You went. Here he just chooses an axis system for an axial system for this asteroid. This is Bennu. It was named by a 9-year-old, I believe. So I believe that's how you'd pronounce it. You'd have to ask him how you pronounce it. So this is the asteroid that we're going to hopefully land on or sample from in 2018. So he chooses an axial system here. So on this one, green, he calls it a z-axis. Then there's a red line. Oh, I did that. Never mind. I didn't realize I had the power. So here's the y-axis. Here's the x-axis. I'm sorry. So he sets up a coordinate system on this asteroid, and it's kind of hard to see, but in this image, he basically is just rotating it. So we're coming back to some of this mapping now, mapping of this asteroid. In this example, he says, okay, we know this asteroid is so far across. We know this picture. This image is 600 by 800 millimeters. He gives all the prescription of what the camera's seeing, what it's doing. So how can we determine how far we are from this asteroid? What? So just simple geometry, right? Trig, simple trig, easy equations. We figure out what our distance is, and that's all we do here. Simple stuff. So next slide. And these are just two examples of he's trying to saying where we pointed at. It's kind of difficult to see again. I know with the dark background, but you can kind of see this spot right here and this spot right here. So you're looking at landmark features is basically the whole discussion again when it comes to mapping. We know we saw something in one image, and now it's at a different location in this image. So you can determine how fast either you're moving to it, how fast maybe that object is moving in space. So next slide. Keep going. So here's the activities. I don't think I'm going to speak to the slides. So what we're going to do is you can break up in groups however much or however size you want to. I'm not sure what you want to do. Last week we had computers. Leslie, do they have computers this week or? Okay. So what you're going to do is take these out. We're going to go out front, and there's two different activities. One of them is this mapping feature I'm talking about. So she got the idea of taking pictures of your license plates far off. I was thinking you could take pictures of whatever you want, but the idea is you're going to fly these helicopters around, and you can take picture. There's a picture feature on here, and so if you go to this last slide, this is the example of what we're kind of talking about. This is just using an image of Google Maps. We get a scale right here. So this is the backside, which we were planning on taking you out. You'd fly the copter around, and you could, take a picture here. Well, then using Google Maps, you can figure out where you're at, where you're located, all that kind of stuff. So that's that activity. And the other one is kind of like trying to think of how they would relate it to that. So the mapping is you would take an image of your car in some sense as you're getting closer to it. And I would kind of be reluctant to do it because these copters are kind of wavy. You might crash into your car. I'm not really sure if you want to. But you're taking an image of that, and you're just trying to figure out where, you're trying to figure out which direction you want to go in order to get to some feature on your car. So it's a similar aspect. One of them we're blowing it up. We're not as close to the object. We have a larger space to work with, and we want to go towards the object. This other one, we're up close to the object now, and we want to go to a specific direction. So I'm giving you the choice. I think maybe the larger one, the larger of the two, like maybe if you want to, create some point, we could talk about it outside. I haven't really looked outside, but we could create some point out there that says, this is our origin, XY axis goes this direction, and you can pull it up off of Google Maps, and based off the pictures you take, you can get an idea of where your car is located on this origin. So this is the kind of idea. You obviously don't have to use this specific type of idea. You could, in the back it's kind of nice because I believe along this side there's some asteroid or like some, I don't know what it actually is out there, asteroid, collected asteroid particles or something. I can't remember what it is, but that's kind of what the idea he wanted to have pictures taken of that. We have interference back there, so we're going in the front. Any questions? I kind of went through that quickly. I know I'm on a time limit. I kind of wanted to see if this worked, had you guys play with it, so I breezed over some things possibly. If you have any questions, go ahead, ask me. Nothing?
As you are pushing it further up, you should be flying off the ground, okay? And so it's just turning right now. You are going to
Crash.
you don't have to worry about it tumbling. It's like kids, they just get up and move it.
They gave you one of those things?
3D.
Yeah.
And click, click, click.
Take some pictures.
I did. Good job.